I'm going to show you a really quick way you can tell whether or not a graph is continuous at a certain x value. So suppose you were asked, is this graph continuous, CTS, at x equals 3? And what you would do is you'd come here to 3 and you'd find a neighborhood around it of x values. Now, where does this neighborhood correspond on the graph? It's the part of the graph that's between here and here. And now moving over the graph in that neighborhood, if I move from left to right, I never have to take my pen off the paper. And so the answer is yes, it is continuous at x equals 3. Okay. Now, what about at x equals 2? Well, if I take a neighborhood around 2, on the x-axis, and that corresponds between here and here on the graph, then if I move over the graph from left to right, I'm fine till I get there, but then I have to lift my pen off the paper and jump over that hole to continue the graph. So I could not keep my pen on the paper the entire time in that neighborhood. So the answer is no. So now I think you get a much better idea of how this is supposed to go. What about at -1? Is it continuous at x equals -1? I think now you can look at it and say no, because there's my neighborhood around -1. It would correspond between here and here on the graph, and tracing over from left to right, I get to here, but then I have to lift my pen off the page to continue the drawing. So the answer is no. Now, that's all well and fine. That's a quick way that you can decide in your head, is it continuous at those values? What if your professor wanted you to prove something was continuous, but you had to use the 3 rules of continuity? That's going to take a much longer video, so I've got it linked, and I'm Dr. Sooze. Check out my channel on the tube to get lots and lots more examples and lots more videos. Thanks for watching.